Welcome to Finding Empirical and Molecular Formulas, AP Chapter 3. Difference between an empirical and a molecular formula. The molecular formula is what we consider to be the real formula. For example, hydrogen peroxide's real formula is H2O2. The molecular formula is the simplest ratio of the atoms in the molecule. So the empirical formula would be HO because both the H and the 2, well, the H2 and the O2 are both reducible by 2. The real formula for glucose is C6H12O6. So what would the empirical formula be? The empirical formula then would be CH2O because each of those subscripts is divisible by 6. So here's our steps to finding the empirical formula. The first thing you need to do for this problem is to convert the grams of each element to moles. So I've converted the grams of carbon given to moles of carbon. And then you do know that you have to subtract to find the grams of hydrogen. And the reason that you're going to have to do this, and a lot of problems are really sneaky like this, see, they've given you a total grammage of a particular sample. I know I said that really weird, but they've given you a grammage of a particular sample, which is 1.500. So here's the total, and then the grams of carbon. So, and it says that the compound contains only carbon and hydrogen, so the remaining grammage has to belong to the hydrogen. You need to divide each of the moles by the smallest mole. I knew that carbon was my smaller mole, so I divided that molage, and yeah, that's my word, that molage, by each one of those. So I end up with 1 and 3. These integers become my subscripts. So the empirical formula is now CH3. Unfortunately for you guys, the problem usually gets more complicated than that. The problem says, hey, well, what is the molecular formula? To do this, you have to be given the molar mass. If nobody gives you the molar mass, you're done. You can't go any farther. So now you need to find the molar mass of the empirical formula, and that EF is an abbreviation for me. It's what I do. It's how I roll. So I know that the empirical formula is CH3. I know that the molar mass of the empirical formula is 15.03, and I trust that you can calculate that. So the next step now is to find the ratio of the molar mass of the molecular formula to the ratio of the molar mass of the empirical formula. And when I calculate that, I get 30 divided by 15, which gives me 2. Final and last step is to multiply the subscripts of the empirical formula by that integer you calculated. So I'm going to look at this empirical formula and go, oh yeah, that integer, it was a 2. So I'm going to multiply this 1 by 2, this 3 by 2, and I end up with the molecular formula, which, by the way, is ethane. Up next, balance some chemical equations.